Toby Considine, as I said, and I'm the nebulous title of a system specialist in facilities, where I've been, one of the tasks I have is integrating the unintegratable. All these things that are in system, buildings that don't talk, traditionally they've been solved by picking a brand. It's an awful lot like mainframe computers were in the 60s. You know, the only decision you made was the brand you picked. And if you're a small campus, SAS, you got 7 buildings, you pick a brand and you go. We are government low bid with every subcontractor being bid separately. So we have everything on the planet on the campus. And so our problems are much worse. And that got me into writing screeds that got picked up in a few magazines. And I showed up at a conference one day and they jumped me and made me chair of OASIS's OBIX committee. OASIS is the Organization for the Advancement of Structured Information Systems. You probably have used several of their standards already. I didn't know that, but I've been wandering the halls and seeing all the XML on the posters. WSDL, for example, is an OASIS specification. You know, UDDI. So these are, you've run across OASIS before, even though you don't know it. And I'm going to skate over 3 different subjects today. I didn't know where people were coming in and what. I give talks at all levels, but this one was a bit harder for me to read than most. So to make this amusing, interrupt me frequently, because that's the only way I'm going to know how to target. So I also have been accused several times of getting vague to the point of almost muttering when I get really into my subject. So I'm counting on you guys in the back row. Let me know.
How about us guys in the front row?
You can have one. But usually the front row can hear it. But sure, you're happy to have it. Happy to have you front row. There you go.
Appreciate it.
The basic problem we have is the engineered world is invisible and, as far as most people are concerned, uncontrollable. It goes and does what it does. You can maybe go and hit a thermostat or call somebody to make somebody do something, but it's not something you can interact with. It's not something that can see. It's not something that you can that responds to you, which means it's not done particularly well. A second big problem we have is that the established business processes throughout the whole capital facility, capital project, capital asset are just lousy. They lose data at every step of the way. Whatever you said you were going to do is forgotten by the next stage of the project. And later on, when you try to verify what you actually got, you no longer have records of what it was you were trying to get. And this pervades every aspect of capital facilities, but particularly the engineered systems within them as well. And the lack of interoperability between systems is just immense. Generally what interoperability is defined as in the engineered system world is, oh, we're using Honeywell systems, we're using Train systems, we're using Johnson controls. That's not an interoperability standard. And the other thing about them is they're not designed for anybody in this room. They're all about what I call the man in the basement. You go back 50 years and maybe you had a speaking tube to the basement and you could shout down at more steam. Guy in the basement cranks it up. But that's it. Now we use telecommunications and networking, and we have a man in the basement out on Airport Road. He can now work with many buildings, but it's not about anybody who inhabits the building. And that's an ongoing problem. And here is the big issue we have, is that we can no longer afford to make decisions that are not fact-based. Right now people assert things, people say things, people say this is green, this will perform well. And we have no idea, we just all nod and yeah, green's good, sustainable's good, who can tell? And that model's now broken. And so the theme of my talk today is that we need to have information standards. I say information standards, not data standards. There's a big difference, I think. That will give us visibility and interoperability. engineered systems are all about data. Is this little tag have this value right now? What does that tag mean? I don't know. I can look it up on a blueprint maybe, but you can't tell what's going on. Can't tell if what it's doing well. So information to me is a fully qualified data point. I've sniffed BACnet packets going across this campus where the temperature had the milliamps going through a probe. Well, great. If I have the calibration data, that means something. Information has to be fully qualified. This is a temperature. It's a plus or minus this. It was taken at this time. Something, and what kind it is. There's a world of difference between something going over the coils, something coming out through the ducts, something going back in the return ducts. It's not information unless you have all of that. It's just a name-value tag pair, which takes us out of standard control protocols. I'm going to be skating over 3 areas quickly. Interrupt me at any time. One is the whole Building Smart initiative, which is a lot of what SIL's undergoing right now. It's how do we design and build and hand over buildings for operation with a focus on information interoperability. Next is OBIX, which stands for Open Building Information Exchange. It's an OASIS committee standard at this point. And its goal is to be an interface to control systems, not the protocol for control systems. And I'm going to say that a couple times. When I use interface, I mean something very particular to me. My wife has a realtor car. She drives an SUV that she can pack whole families in and drive up over the curbs in new construction areas. And it has a control system to me that feels sloppy. But she likes it. I've got a little sedan that's got a VTEC engine that adjusts how it carburetes based upon how aggressively I'm driving. The control systems of the two are nothing alike. The protocols being used inside are nothing alike. But the interface, this one makes it go faster. This one makes it slow down. This one makes it go from side to side. This one tells me how it's doing. That is standard. There's variations in that interface. I got one of these things on the floor. My wife doesn't. But if you understand the interface, you can sit in any car on the planet. So to me, the focus of standards is on interfaces between systems. So when I say interface, that's what it means to me. The other thing I'm talking about is something that maybe is a little bit further afield, but I think it fits. It makes a nice little troika, which is the vision of the Gridwise Architectural Council, which takes the same stuff, the same interoperability and interfaces, and puts them on the power grid to turn the power grid from being the unknowable, ineffable thing out there, instead to something that you've got an intelligent grid that your intelligent building is negotiating with and interacting with. So those are kind of the big themes that we're going to go over today. Starting with building stuff. Traditional practice does not share information. They just don't. You may not even use the same architect that did the initial programming on the building. You may not have any of the information. You have all kinds of things that don't interact. Every stage of a building acquisition is its own silo. It shares the information about nothing. These two factoids are well known out there, but I can't come up with a source for them. But every architect, every member of the AIA has these two bullets that they put together. So that's a lot of waste. That's a lot of cost. NIST tried to actually identify it, and they came up with just a $16 billion per year cost in the US of information interoperability, or non-interoperability, a couple years ago. A report you can pull down off the web if you like. That's what they could identify. Everybody involved in the study thinks that they barely got the tip of the iceberg. But that's just what they could nail down. So, and that's, so let's talk about design intents are lost before you design. Design intents, that's the process where you go in and say, what do you want the building to do? Usually it's some guy in a nice Italian suit, sits up front with the flip chart, talks for days while you eat bad takeout, and he writes all kinds of goals, and you may never see it again. This is our standard construction process.
We've done that, Mark.
Yes, yes. Energy models have nothing to do with the design process. I know you're going for a LEED building. I know you're going for a green building. Our accepted business model, business practices that we use as a state agency don't include energy modeling. But you can say you want to be green, and they'll say, okay, if you've got some extra money, we'll do an energy model. We don't know how to do an energy model, so we call the architect. He calls somebody, I don't know, maybe somebody good, maybe his cousin, we don't know, and does a $75,000 energy model, but it may have nothing to do with the design he's working on. Again, we've got our LEED star, we've got our LEED points, and we go on.
I just have to throw this in. I just will bet $1 million that these energy models don't include modeling the turning on of heaters in the middle of summer because the offices are too cold in a way that can't be controlled by the inhabitants of the offices.
Yep. But even if they were monitoring it, it would be invisible. The only guys who could see it are the guys out Airport Road.
Yeah.
So, yeah, that's a huge problem. And that touches, by the way, on one of the big issues that when we get to power grid interoperability, we can design it as well as we want. We can include all the pieces that we want. But unless you can read the live burn rate coming through the electrical meter right now, you have no idea if you got any of that. And the business model is we add up all those instants for 30 days, and then 2 weeks later send it to you, and you got a number. That's not feedback loop. It's, that accepts everything. But so this energy model, let's assume that you even did it right, and you actually did it exactly off the plans and exactly what's made. Well, then 3 months later, someone comes up with a budget and says, ooh, that's a lot. And we do what's called value engineering, which means crossing things off the list and seeing if we can get something cheaper. Then we don't do a new energy model, because that would cost as much the first time, because there's no links between the design and the energy model, because there's no information interoperability. Conflicts. The biggest kind of conflict is spatial conflicts. Anybody who's walked around a building knows that there's kind of a race between the trades. Can the plumbers get there before the mechanical guys do? Because then they can put the cheap locations for putting the plumbing in, and the mechanical guys will have to route their ductwork around the plumbing. Or if the other guys get there first, vice versa. Well, what does that do to the energy performance that we allegedly got? Well, we don't know. Because none of these problems are resolved in advance. Because you go through these drawings, and you have a very pretty drawing that was made as a one-dimensional object. I mean, a two-dimensional object. You've got that nice little sheet there, and there's the pretty floor plan. You flip it, there's the pretty ductwork. You flip it, there's the pretty pipe. Do they all go through the same location? Nobody knows. That's left to be discovered by the contractor. And covered by change orders in the most expensive way we can. So that's kind of the problem. You can't design performance green buildings in this way. It's just, if you've looked at the LEED stuff, most of it's extrinsic to the process. If you build in a parking lot, you get green points. But what's the usual business process of the university? We'll take any site that we're going to build on in 10 years and pave it now to get parking for a few years. So we get extra green points all the time. Doesn't have anything to do with sustainability or good process. But most of LEEDs today is these things that are kind of external. So a good model that shared data would use intrinsic energy models for commissioning design. By that, we mean you look at the actual blueprints and generate in electronic form and generate the energy model directly out of them. That's a process and a workflow that's until recently was called NBIMS, the National Building Information Model Standard. But the problem is BIM is a heavily overloaded acronym. It means a lot of different things to a lot of people. So now they don't call it NBIMS anymore. It's still a national standard. It's still sponsored by NIST, the National Institute of Standards and Technology. The guys who make sure that a nut from this company and a bolt from that company screw together, it's still, but now it's called Building Smart. Bizarrely, with a little b and a big S as one word. I hate it, but that's what they came up with. Not only in the US, but worldwide it's called Building Smart. But it's, the energy models can be run directly out of the building model if you're specifying it. Which means that when you change the building model during value engineering, you could redo the energy models without starting from ground zero again. That's a big difference. That means the energy models stop being greenwash that you do to make yourself feel good about yourself and start being something that actually affects what you're buying and what what was being designed. That offers an interesting concept. I mean, right now, commissioning. Commissioning is really big. One of the ways you get green points is by you commission a building. But commissioning is ill-defined at best in traditional models. One time I was giving a talk to a bunch of mechanical contractors. And I asked rhetorically, what does commissioning mean? And one guy in the back row, I just love him. Without missing a beat, he says, no sparks. And that's, alas, what a lot of commissioning is. It doesn't say, is it performing well? It doesn't say, is it performing up to design? It doesn't say, is it performing as we wanted it to? I came in, it's cold, there seems to be some airflow. Okay, check off this room. Does that have anything to do with what you're doing? An intrinsic model, just going across energy, would say, we have our design intents. That's how I want it to work. We look at the energy model, which is run out of the design, and then apply that to see, does it meet the design intents, which means we've got to have recorded them in a standard format. When we're commissioning, then we have every system in the common information model already listed, what kind of energy it was designed for, what kind of performance specifications it had, and commissioning then becomes comparing the results to the energy model. So the energy module commissions the design then, and the commissioning compares that. That's an integrated data lifecycle. One of the things that's really good about CILs is, so far at least, I don't know if they're the, I don't know, are they the project architects yet, or are they just the design guys?
At the moment, just the design.
One good thing about them, and I'm not trying to influence the decision, and I am not the, et cetera. But so appropriate caveats. They are saying things about like data stewardship and stuff, which is talking about that information life cycle, which requires standards. And I'm not going to show you the IFCs; they're boring. I'll give you some links, and you can read them if you want. But it's just a data format. The important thing is that the data format is out there. That if you use it, you can maintain that information over the life of the building. Now, if I have live feeds, and I can somehow read information from the control system in a standards-based way, then not only can I commission the building day one, but we should be able to look at the performance of each of those systems every day and tell you, is it still in commissioned state? Not just was it hot or cold, but is it performing as designed? That's a big difference from the normal model. And quite frankly, that stuff is now a hot area of discussion within the standards world, and is not fully aware of that, but clearly there's a big win. One of the dirty secrets of the U.S. Green Building Council, which they'll happily confess after a couple of beers, but not when they're doing their PR work, is that better than 80% of all the platinum buildings are absolute energy dogs 1 year out. Because they were not designed right, they were value engineered out of it, or maybe they used some aggressive, edgy strategy that rattled and made some noise, and they kept on calling facilities until someone put a brick on the damper and the noise stopped and everybody's happy. Whatever the reason, they're not performing the way people hoped after all that extra expense and time. So, clearly there's a problem across the board at every part of the performance of a building because we lose data, because we lose information at each stage. And so what Building Smart suggests is that we have an integrated information model to change something. Now it's the old principle. If you keep on doing what you've always done, you're going to get the results you always have. This is the change. This is where we're going to. And of all the customers that facilities has, this is a group that's probably better positioned to seize the initiative of this than a lot of our customers are. Because you understand the information. You understand analytics. And indeed, this is one of the big areas. If I want to get a bunch of building system engineers and CTOs of controls companies excitable, I put the word building analytics on a slide. And I'll go, wow! And then say, what's that? And I say, I don't know. So, there's an opportunity to help change things here too. Single model reduces cost while speeding construction. One of the standard things that you get, and there's a reference at the end. I've got all my references in the last slides because that's just what I do. If you've got a single model, an awful lot of what a contractor does is they pad stuff because they know they're going to have to cover things that weren't discussed. If you actually give them an information model to work with, and they know they're not going to have to reroute the ductwork by surprise, and they know they're not going to have to fight with you about this or that, they can give you a fixed price that's considerably lower than they might otherwise. And the other big exploding thing in every construction budget is the reserve for change orders. Change orders are very expensive. And you've got a bunch, and most of them are fixing things that were not resolved in the initial design. Sometimes there's a new program and you have to do something on the second floor, but mostly it's problems that should have been resolved. And you can eliminate them. There's a report out on the web right now about a wet laboratory renovation. There's a biology building at UC San Francisco. Urban situation. Every time construction works, let's block off 3 lanes of the street while you stage something. That says expense and that says overrun. Wet labs, that says change orders. They committed to a building information modeling approach. The design cost more than the traditional design did, but they expected that. And their construction bids came out 38% under their budget. That's large. You pay a little bit extra design for that every day. Your mileage may vary, but that's a report that's out there right now. They also completed it on time, which is very rare in an urban project, and without change orders. Some of the cost stuff was the duct was actually measured and verified, and the designer warranted their work. That's liability. One of the things you have to pay the designer for is assuming liability. So the ductwork was pre-fabbed at the factory, pre-sealed at the factory. That made it higher performance and cheaper. And it means that it spent less time in the lane of, blocking off one lane of the street while somebody fabbed it on site. Big sense of cost from having a unified model.
I have a question.
Sure.
How reusable are these models across buildings? I mean, do you have to do this from the ground up for each building, or are there other
yes and no.
aspects that you
Yes
can
and no. They're
contemplate?
tools. You can say this is a wall and say this thick and it's masonry, and the system knows what a masonry wall is.
Mm-hmm.
So you don't have to come up with the thermal calculations again. But that's like asking how much do blueprints carry across buildings? It's the same question. There's not a whole lot of evidence that models take longer to build than blueprints.
Okay. But that's the computer now.
Yeah, it's all CAD. But instead of being drafting, it's design. CAD is all about automating the drawing process. Under modeling, the drawings are projections, are views of the underlying data.
Mm.
So it's just a visualization strategy of the underlying data. So they're not really interoperable, except if you're, Wake County schools are in a huge school building process right now.
Build the same
And they
building.
build the same thing 50 times. So of course those models are in.
Yeah.
But now you also think that you want to create feedback from actual operations to future designs. That requires you keeping that information model. And again, that's one of the things the designers you're working with, who, by the way, they wrote one of the seminal papers that really kicked off the whole Building Smart initiative back in about '98, which is they would talk about being able to collect data after delivered, so they've got a feedback loop. And the traditional model, I shoved it out the door when I gave you the blueprints, and I never see it again in this architect's model. But those feedback loops are something we need to have going forward. So that's kind of the design story and why you want building information models for the design stuff. Higher interoperating performance is also going to require interoperable interfaces. There's lots of things that people are talking about now when they talk about highly operating buildings. One is site-specific changes, which may mean that you may have to use a different system for the building on the north side of the slope than the south side of the slope. One of the things people talk is about zero-energy buildings. Well, they don't use zero energy, but they generate some on site. The site generation strategy might be different for every building. You know, the guy that you get who's a really good HVAC guy, he's probably not good at solar power. So you need to have interoperability, high-level interoperability, not low-level we can plug them together stuff. And you also want to maintain accountability for each one. My system would be performing, but I keep on getting signals from those guys over there. You want to have that interface well designed, standardized. So control protocols are just a mess. This is not control protocols clearly, but they're all plugs, they're all different, they don't match. You look at them and say, why do these both exist? I don't know. They're out there. And as I touched on earlier, control protocols tend to be very low level, very detail oriented, very, mostly what you get out of them is you manage name value tag pairs. So here's a tag, this is the value. This is the tag, this is the value. And if you happen to have a database of calibration data, and if you happen to have a schematic, and if you happen to be an HVAC mechanic, then maybe you can figure out what it means. Well, that doesn't interoperate in a bigger layer. You need to have abstractions above that so you can have the systems interact, so you can define what the interactions look like, so you can audit them. So we've got to move out of control protocols, I believe, and up into protocols that look more like business protocols. Now that doesn't mean I don't need a business protocol in every sensor above the ceiling. I need a business surface on the system that's above the building. Control protocols are too complex to integrate into operations. This is a chart that came out, someone's describing system complexity in an academic paper. And it just set the problem. If we have to connect everything to everything else, if to know how to operate this system, you didn't know about what is the time sequence that needs to be in place for the reheat past the coil on the HVAC system, you're never going to be able to do interoperability. You're never going to be able to share it. You're never going to be able to, inside a control system, you want to pay someone to solve those complex problems. And then, just like in the car I was talking about, give you a simple interface that lets you deal with it. And if that guy did a bad job, you want to be able to toss out just that system, get somebody in to do it right, and still come back to that same interface. So interoperability increases the competition for higher performance, which is something that we don't really have right now. Mostly the controls world right now competes on what I call rent seeking. We got in there first, and it's so hard to integrate with anything else, we'll use the same brand on the next building. But if we're going to actually get new models and performance, we need interoperability in services. I got an interesting feedback from the last talk I was in that used this particular diagram. This is a professor of control systems and large-scale integration at Old Dominion. His previous work was on the pan-European missile launching system, so he's been working very large, complex systems. And he said he can't effectively tune a system if it has more than 9 interactions. And he says that the guys that get A's in his classes can tune them up to 7 layers of interactions. So we've got to simplify the interactions by hiding them. If you and I decide to go for a walk around the parking lot, I say, let's go for a walk. I don't say, okay, that wouldn't work. And that's what control systems traditionally have done in the integration. The other thing that we've got to do is we've got to get away from monolithic protocol stacks, which are what every control protocol today is about. And programmers used to work with them and say, oh, but that makes it simpler, and I need to have access to everything and control everything. Does everyone recognize this protocol stack, which is actually a simplified version of this stack? I could put about a half dozen more in here. It's one that everyone uses every day. It's email. It deals with changes. Some of them have HTML or not. When you send email to someone that's a pretty email and it comes back plain text, you know that their email doesn't support HTML, but The interface wasn't affected, the interoperability was not affected. Composite protocols are the basis of interoperability, because that allows you to have variation within theme and within defined services. And that's quite different from the way control systems traditionally have been done. The last thing that control systems lack is any kind of nuance of security. Because they aren't about, because they're name value tag pairs. How do I, what does it mean to secure the sensor on that fan coil? From who? From what? It just doesn't mean anything because it's just a sensor, it's just an actuator. So those are kind of the problems of the traditional approach. But after we get interoperable standards, then we can move up to something that I would call service definition, which changes how we think about it. Nobody wants to buy electricity. And what do you do with it? You know, you can stick it on your tongue and get a jolt, but nobody wants to buy an HVAC system. You buy services. And that's how these things need to define themselves in terms of services. I was talking with a guy who runs a very large, he's in charge of facilities for a very large chain of drugstores. And he buys 3 services when he buys HVAC. And most of his energy dollars are spent on HVAC. He's got one service, which is, I want people to feel that it's more comfortable than outside when they first come in the store. A blast of cool air on a hot day, a blast of warm air on a cold day. Doesn't much matter what temperature it really is, it's just as long as you feel good when you first walk in. So that's one service. Next service is he's got a regulated environment. He not only has to maintain delicate biochemical substances that are very labile in ways that they do not degrade and be able to prove it if the feds come and ask him how well he's keeping the drugs counter. So he's got a regulated environment problem. And if you're in that part of the store, the information needs and the quality of service are entirely different than at that front door. And the last standard is the standard that's in the warehouse. The only thing he wants in the warehouse is don't melt the chocolate before I put it on the shelves. If you do that, then he's happy. So he's buying 3 things. The proxy for buying is he's buying 3 HVAC systems for each Walgreens he puts in. And the proxy for that is electricity. We all talk as if the air conditioning is important. To him, the chocolate's important. Yeah, it's nothing chocolate. So, that's what I think. We need to really think about what are the services we're getting, because then into service analytics. Then you can start saying, how well is it performing this? Then those green and sustainability questions all start talking about value in the building rather than some process that nobody really cares about but have to learn about.
So can I ask a question about that? So as you think about buildings on campus, what kinds of equivalent statements would you make? I mean, I would think of things like, it has to be cool enough so the students don't fall asleep after lunch.
It might be. Well, that's an interesting question. It might be that you want to change the cooling strategies right after lunch for blood sugar levels. It might be. You have different. That would be an interesting conversation. It would be an interesting conversation to track that in 4 buildings for a semester and say, now we know what our standard is. We are talking right now that as the registrar's office goes into ERP, which we hope is service-oriented, that one of the interfaces to the registrar's office that we want to receive in our central automated man in the basement I was talking about earlier, which we call EBMS. EMCS, Energy Monitoring and Control Systems, is a long-known standard, and it's all POX control speak, and we wanted something different, so we called it Enterprise Building Management System with enterprise interfaces on it. What it does is we're asking right now, can we get an iCal? When you get a meeting invitation and there's a little thing in the corner that you can click on and then it's on your calendar, that's a standard internet format for scheduling. If you look inside that, there are things that will let you know, for example, there's 20 people at that meeting you're going to. We'd like to receive an iCal for every class into the EBMS system so we can start operating the buildings based upon what's actually in them going on rather than, well, I guess we have to turn it on at 8 o'clock and turn it off at 5, and that's all we know. So that might be a service integration. There's also things that, less over here. If we have a airflow failure from, I think, 14 minutes, someone told me once, in a laboratory animal quarters, we start having animals die. Got a different service requirement there. There's so many animals packed in tight space, which is a perfectly healthful environment as long as you're turning the air a lot. So we have different kinds of spaces here. I'm sure whatever space they have now that replaces where I did my freshman chemistry classes has special requirements as well in terms of ventilation. Right then, they just had really high ceilings and open windows, but I don't think we do that anymore.
And for us, it'd
Box
be how many
fans.
computers you got running in one room.
Yeah, so there's, so those are the services. You mentioned an interesting thing, which is computers in a room. What is the cost of having a computer room 5 degrees too warm? You can't tell. Short term. Long term, things happen like the oil on the disk drives evaporates faster, so you have disk drives failing 6 months before they would have otherwise. Can you tie that to a particular point? No. But, so, yeah, there are different, we have lots of service standards, but we don't talk about them. Because we're still in this process, I'm going to fire up this actuator and this control loop. So, we want to have site-based system selection based upon common interfaces to allow things like zero-energy buildings, to allow things like site control, to allow things like the thing that the guys at ITS Manning would like most is just being able to read the chill water temperature on the 6 buildings upstream from them. Now, we have a business process and memorandums of understanding that say what we're going to do is we will, if a big steam chiller under high pressure blows out, the first thing the guy in the plant will do is run to call the control room. Yeah, right.
Mm-hmm.
He's got steam squirting all out. He's going to be doing that. We just give them access to actionable information about just what is the temperature on the 6 buildings. If they see warm water coming at them, they can start shedding load. They get control and autonomy. So autonomy is a service as well. That's based upon, even if I don't let you interact with the control system, just letting you know what's going on. So then the question comes, what if the building was part of your service-oriented architecture? What would you do? I just told you what the ITS Manning would like to do. How do you have things interact with how you're doing things? How does the building interact with the fact that you just scheduled a seminar this evening in your calendar system, not by calling somebody in facilities? And it doesn't have to be the heating and cooling system. How does the security system on the front door interact with the fact that you scheduled a seminar this evening? How, if we took all the muck down here, constructed into standard functional components that provide services, and then define them, how would you do things differently? And then it goes back down too. There's a wonderful story that I was giving a talk, and actually one of the owners of the building said, "Oh, that was my building," so it's kind of a nice feedback. This fall, there was a big heat wave in California, and a hospital turned off its air conditioning system entirely on Friday afternoon and said, "We'll turn it on at 8 o'clock Monday morning." Well, it was a dumb system. It did what was asked.
Gave them beds.
What?
Gave them beds.
Well, they turned off the clinical space. So it wasn't affecting beds, but at 9 o'clock, it was still too hot to use for clinical space. Same at 10.
On Monday.
On Monday. Same at 11. It was after 3 in the afternoon before the space was up to standard. And furthermore, all that catch-up cooling happened during the day when electric prices were expensive again. So right now, because we're all control and process oriented, the system turns on when we tell it to turn on. As we get to being service oriented with agents, we instead will be telling them, be ready at 8 o'clock Monday morning. And then you've got some engineer who studied the stuff very carefully, knows the temperature and humidity outside, knows the capacity of the building, knows the previous performance, knows how expensive power is right now, and decides that 3:30 is the right time to turn it on. But that's when it starts turning into a service rather than a process. The last thing that you need to really be able to allow these things to open up is situation awareness. Without situation awareness, services just cannot be shared. You've got limited interaction. And situation awareness means you need to not just know who is doing what, but what is their role? What is their role right now? Which means that we now have a new part of a construction project, which the system integrator has to define what are the system roles. Who's allowed to do what? What can a tenant do in a building? What can the departmental administrative assistant do in a building? And that's not actuated. Those are business functions. Those need to be exposed up so you can begin to make the buildings responsive. That's going to require some protocol stack that looks more like Federated Identity Management than it looks like 6 passwords that are known to an embedded controller. And that Federated Identity Management has got to be roles-based, so that when someone changes jobs, the rights in the building change. And we're not going to update the building control system first, because, if you say it aloud, it sounds silly if you do that. So we're going to have to be getting into real standards for sharing identity and role and authorization. But once you get abstraction security, then you can enable interaction. And in our EBMS system, our programmers working on it were burned out one day, so they went and spent far too long at the mall after lunch. They just couldn't program anymore. And there was a Macintosh store at the mall, so they wandered in there. And they ran a building management system over the demonstration iPhone at the mall. Because we're starting to move to standards, move to standard interaction. And they said, that's not fantasy. We can do that with the system that we're just about done building right out there right now. But how are we going to interact with your systems? We don't know yet. We don't know. We're hoping our customers will tell us. Now, phase 3. Smart buildings are necessary to solve the biggest problems we have. And one of the issues is that buildings that are not responsive are not efficient. That goes back to what I was talking about the registrar's office. If we don't know when there's actual classes in this building, how can we claim to operate it efficiently? If we don't know that there isn't anything scheduled in this building on Tuesday afternoon, how can we operate it efficiently? This is a simple slide. These are both have decimal points after them. The simple version is 40% of the energy going in the U.S. is operations of buildings. You can have a tree planted in Nairobi every time you fly a plane from now to forever. It will never touch the opportunities for saving energy on large scale that are in buildings. 62% of the power that goes over the power grid is for building operations. If we can get a 5% change in building efficiency, that's bigger than any other popular project that you've heard about recently. But buildings do not interact with their tenants. They do not know their tenants. I've gone through this, so I'm not going to spend time on it again. I never know how long I'm going to spend on each slide in advance, so sometimes I do that. But Department of Energy, when talking to me, says that they think that 25 to 50% of the energy used in a building can be improved by making it responsive to the tenants. That's not to say we shouldn't change the building envelope to be better insulated. It's not to say that we should have more efficient systems. But if you have a building with the envelope you have, with the mechanical systems you have, everything else, but it just has one additional detail, which is responsive to the tenants, they think 25 to 50% of the energy in the building is on the table. Yes, sir.
Question for you, kind of the responsiveness. So part of it's the schedule, like we said, we have a meeting in a room. And what about sort of unscheduled activities? So if we're in here, is there work to sort of incorporate sensors, like say if you body temperatures to recognize the fact that people in the room, and to have standards to incorporate that back into the building?
The thing about standards is there's so many of them. Yes, there are standards for that. There's a lot of them, that you say to incorporate back in the building. There's ways to put sensors out there cheaply. Zigbee's the one that's getting lots of mind share right now. Dust is out there as a developing standard that might be the dark horse in that operation. But there's ways to sprinkle sensors all over. Dust is a very neat one to my mind. chief problem of having an unwired sensor is you have to change the battery. If I have to get to the other side of the building with that wireless sensor, radio power goes up as the cube of the distance I have to travel. Because I have to change this battery regularly. Dust is a set of protocols that says I'm going to put lots of things out here. They will find the least path back by passing messages between them. Which means now that sensor only has to throw something this far. And the batteries basically last forever in terms of that sensor. And you just put new ones out when ones die. So it changed the whole model of making, so you can have, there are efforts to make heavily sensed buildings, but they're not going to do something if we're doing control process. What those are, I think properly understood as is those are auditing on the service provision. And you want to make the system small enough and intelligent enough that can be responsible for providing a service level. And that's the way we'll get to what you're talking about, I think.
Are there any examples of this on our campus yet? Or,
Craig?
None of that.
No, and this is, I'm not describing to you facilities policy or a standard building or business models that have been accepted by the State Construction Office. I'm involved in international standards bodies, and this is the way it's going to go. But applying it to the ground is, something that customers have to drive through the administrative processes into. That's a different beast. There's some stuff in RENCI on the pervasive sensing. Who can tell what RENCI's up to this week? This is our responsive to the power grid right now. There's something, GridWise is an effort out there that says, what if we could make intelligent buildings negotiate with an intelligent power grid through a standard common interface that looks like business stuff. Right now you got 30 days of use and you sum it. You can't have a feedback loop, you can't do monitoring, you can't say is it high performance. You can't say anything, it's just, so that's a barrier to proceeding. The power grid is run just lousy. For those you can't see it, listen to 11 here, so you might know where this clip was pulled from. It's from my Spinal Tap, where they said, I prefer this brand of amp because it goes up to 11. That's how we run the power grid. Someplace in Western Carolina right now, there is a spin reserve, a power plant that's spun up, but not under load, just in case I do that. Because electricity has to be there. That kind of inefficiency pervades every part of the power grid. So they just design it so that it works most of the time. So two-way communication says, what if instead of doing that, the power grid could say, I got a little bit of extra right now, or if you turn on anything else, I'm going to have to spin up something new. Is there price negotiation there? Is there business negotiation? Well, that changes the way we think of buildings. So, by the way, on the same token, every time there's a renewable energy source that might have a cloud go over it, or might have the wind stop blowing, there's a tax. It's not government tax, but there's an economic tax on it of having live reserve nearby to take up the load should the wind stop blowing. That makes every kind of renewable thing much more expensive. So, live markets and energy. And I say markets because that's how we communicate abstract information. The most understood and most abstract information we have is green dollar bills. Everyone understands them. We know how that's a statement of value. We know that's a statement of principles. You do this, I'll give you dollars, okay. And then people can negotiate. It's clean and it's not involve people in other people's process. One of the big things coming out right now is open meter standards. The biggest problem with open meter standards is a lot of the utilities right now, working through the Public Utilities Commissions, are preserving a standard that says you, as the building occupant, don't have any right to read your meter data right now.
They don't want it open.
No, they don't. No, they don't. Our own, on campus, we're having trouble fighting that battle with our own internal electrical group. Largely because those guys work here for 5 years, and work there for 5 years, and work back, and the reflexes are so deep and so ingrained that, just, a customer might not understand that information.
Toby, on that point, the electrical meter on the transformer feeding the building that we share
Uh-huh.
is a style of meter and technology that's web enabled. It could be talking to us now, but is it? No.
No, the revenue grade meters we've been putting in for the last 5 years all have 2 RJ45s on them. One for the power company, one for inside the building. By policy, we're not using the one for inside the building. Building agents, and I say building agents. I don't think, there's some guys, I was talking with some guy from EPRI a couple weeks ago who was talking about mapping things right down into the control system, but you don't want to be under the control of the power company. I was talking to Horst, guy in charge of demand response for Whirlpool. And he said, if he's got bleach in the washing machine, he's not going to turn it off just because the power company said so. He's going to wait till he's run a rinse cycle and then turn it off. So even simple things like that should be defined as services rather than control. And when we do that, then we can start saying, well, how much is it worth to me to run the washing machine all the way and keep the clothes safe? Well, that's a decision I can make then. But only coordination that is simple and secure will scale. When I was an undergrad, I took a social dance class my first semester. Freshman guys are low on the totem pole. They're pod scum. And I wandered in this room, and there was about an 8-to-1 ratio, and I like this. Next semester, can I audit this class? And the instructor says, yes, you can audit it. And this was good. And I audited multiple semesters as an undergrad. And one of the things I found, though, in a hurry was that if I was dancing with someone and she was still muttering under her breath, 1, 2, 1, 2, 3, it wasn't time to dip yet. You've got to get things up above the low-level process before you can make them scalable and interoperable. So, per data and shape of campus is at the heart of some very large problems. Problems of sustainability, problems of cost, problems of affordability, homeless, whatever you go, there's a lot of money on the table and a lot of resources that are being wasted. Poor design standards, poor building operation standards, poor interactions between buildings and the grid. And we need to move to business practices that are based upon open information sharing, because the opportunities are just immense. And this place, actually, to my mind, is an opportunity, and I don't mean the sales building a new school, but in terms of things like building analytics, is the kind of thing that's what's needed to convert these low-level control systems into services. And that's something that nobody really knows what that even means today. This could be a place that discovers it. It's got the right intellectual capital. And we could apply the best practice from IT, and by that I mean, in this case, service-oriented architectures rather than deep integrations. The acquisition and operation of capital assets, there's a lot of stuff in play, a lot of stuff that's very important. Agents, I keep on saying agent a lot. Agents are an interesting thing. The best way to think about an agent, it's an object that can say no. Mostly you have things, you tell them to do something, and they have to do it. But an agent's job is to preserve its mission first, and then respond to you. And, if I let you have access to the HIVAC system, and the next month we gave a lot of sophomores Legionnaire's disease, that would have been a bad thing. There's missions that each of these systems have that none of us are supposed to mess with. We want them to preserve those missions, and then within their mission, negotiate with us. And that's where the biggest opportunity, I think, is, because that both drives performance expectations down into the agent and enables secure interaction with the rest of us. So, yes, sir.
A lot of the things that you described are technological problems, but then it seemed like clearly a lot of the problems are institutional problems.
They're institutional. We know how to do the technology.
So,
We've known how to do the technology since the 70s.
So you're involved in this OASIS effort. I'm a little
Standards.
surprised that OASIS is doing this. I assume there's other bodies that do, like ISO, that would do standards. So why would OASIS, why is OASIS the right place?
Because we want it to be e-commerce. One of the biggest standards, for example, in North America is backwards. That's an ASHRAE standard. the American Society of Heating, Air Conditioning, and Refrigeration Engineers. Refrigeration and air conditioning engineers, I got that worked out. But anyway, the guys who come up with the standards to keep you from getting engineer's disease. But they're all thinking about controls. They're very detail-oriented engineers, and they would love to share their information with you. If you can only just go to school for a couple of years to learn the standards. And they're very low-level detail. Don't let me get in the way of things. You get a lot of that, in the IT shops too. I just want to have direct access to all the data and I'll do everything. That's why I say services. Because without services, we're not going to have big scalability with these functions. Anybody, well, any good group, can put together a single building that performs well once. But we've been doing leads now for how many years? I don't mean we here, but in North America. What % of the building stock has been leads enabled? Assuming leads was actually a standard that got performance. It's got a long way to go before it even gets up to 1. We need to have a model that's more sustainable than talking about the low-level things. And to me, that means bring it up to a business decision, business-level standard, business-level interface. And that's what's an Oasis. So ISO, I mean, I've worked with ISO guys. I actually have the chair of the ISO committee on home and building automation is one of the guys who sits on my committee. And we talk to each other. But there's a really strong belief that this needs to be business interfaces, which an Oasis is big at, rather than engineering and control interfaces.
And do you see obstructionists, like, say, for instance, the companies that don't want consumers to control the meters?
Yep.
And do you have any sense of how easily those people either be brought into the fold or cast aside?
They're in a difficult problem. For the last 50 years, the market has all been about rent seeking. I've established a position, and I'm going to maintain it, charge as many people as they can to come into the space that I've got, and then try to expand my sphere. That's not a good thing for interoperability. And in many ways, you can map it analogously to some of the stuff that's gone on in the IT world, where certainly when I started on the New England timeshare Pun 10 bot, it used to be coupler, everything was all about brands.
You're describing IBM.
I'm not sure for a second.
Well,
Yes,
there's,
but yeah,
no,
yeah.
not in that,
But yeah.
the general.
Yeah. So that's not just IBM, but the entire IBM and the 7 dwarfs. All the 7 dwarfs are what the controls world is like now. That's the question is what breaks that market? There needs to be some cataclysmic event that breaks the whole thing. There's a couple things coming. One, of course, is the whole sustainability initiatives and carbon and all that kind of stuff. That's one thing. There's another one that's launching up right now on the consolidated university level, which is the Healthy Building Initiative. It's trying to do to healthy buildings what the U.S. Green Building Council has done to sustainable buildings. That initiative is coming at it from another direction. And it's going to need to have measurable results of information, not control points. Another thing that's coming out that's terrifying to everybody is China. My co-chair on the OBIX committee was sent by train to do a kind of walk in the woods, a vision quest, a few years back. And he arrived in Singapore, and they said, yeah, we've got these, do you have any systems like this? And they said, yeah, and they showed him something. He thought, wow, this is pretty cool. We sell these for $130, and they're selling them for $13. He said, wow, I'm going to have to write back to headquarters and get something to do something about this and so on. And his next step on his walkabout was to China, where they showed him similar functionality for $1.30. So right now, the Chinese stuff, and with all the hits it's taken on lead paint and stuff recently, still it's 2 orders of magnitude cheaper than the controls we're doing here. But until they finish building Shanghai City, we don't have to worry. They will. So their whole model of rent seeking on high fixed margins, and we're going to do the system integration for free because we sought to sell you the goods. Well, that means that they're bidding in the future and doing all the integration work based upon a multiplier on something that's going to drop 2 orders of magnitude. That's got them scared. And there's lots of things out there, and but is it going to crack tomorrow or next week? I don't know. I know that we have, we are a couple months away from having 60 buildings on campus running aerobics. We are 2.5 months away from having a little over 100 buildings that we do about all monitoring and operations exclusively by web services. So, it's coming. That's just not standards-based, it's not as abstract as I'd like, it's not really service-oriented yet.